Now we get to a very exciting topic, and that's called combinations. The first time you meet combinations, you're going to be quite amazed by it. Now, we all played this little game at school. We've got, imagine we have 10 children on the playing field outside. We've got 2 captains, and they've got to make 2 teams of 5. So they've got to choose 5 from that set of 10. Now, let's just play this game a little bit differently. We let one of the captains decide first. He or she can go first, and from those 10 children, he or she can pick 5. And you've got to ask yourself, how many different teams can that captain come up with? And the answer might amaze you. Remember, only 10 children, you just have to pick 5 of them. How many different teams can be made? And there you see the answer. 252 different teams. Just from choosing 5 individuals from a group of 10. That's actually quite amazing. That amazes me. Now, 252, that's a bit difficult to explain. So let's just go a little bit low in our numbers. Let's have 4 colors. We're going to have red, green, blue, and yellow. And we're just going to say from those 4, let's make groups of 2. How many groups of 2 can you make? Well, it's quite easy. There's 6 combinations that we can make. It's really going to be the red and the green, the red and the blue, the red and the yellow, the green and the blue, the green and the yellow, and the blue and the yellow. It's easy to do. Now for something more exciting than the colors. Let's play the lottery. This is actually important because some of us spend our money on the lottery. Now in most countries you have to pick 6 numbers, and you pick from a possible of, say, let's make in our example here from numbers 1 to 47. So there's only 47 numbers to choose from, and you've got to pick 6. How many different combinations do you think there are? And again, we know it's very unlikely to win the lottery, so you can imagine the number is quite large. But it might amaze you to find out that there's more than 10 million different combinations. 10,737,573. That's enormous, and that's why you don't win the lottery. Because if you pick 6 numbers, that's 1 in 10,737,573. So I worked it out for you there, what your probability is, your likelihood of winning the lottery. It's actually very, very small. No wonder they say playing the lottery is just another form of tax for people who don't understand mathematics. Now, all fun and games apart, there's something serious hidden behind combinations, and something that you have to understand in order for you to understand the statistics that we are dealing with. Now, we just saw that we had 47 individuals, and we had to choose 6 from that. We could make groups of 6, and that gave us over 10 million different combinations. And that's quite amazing. But now, think about it in different terms. Imagine you were to do a study, and there are 47 and 6, those 2 numbers involved. So what can we do? Let's imagine instead of 7 billion of us on the face of the earth, there are only 47 people, and you want to do a study. And in your study, you want to include 6 individuals. So from that 47 people, you're going to take 6, you're going to measure some variables, say their white cell count, whatever, and you're going to calculate a mean. And you might make 2 groups and compare those means, but how many groups could you have come up with? Just 47 people, just groups of 6. Over 10 million. You would have been able to calculate more than 10 million separate different means. And that's just from 47 people. So imagine we ramped that up to 7 billion people, and you included in your study just 30. That mean that you could work out for whatever variable is just one of almost a countless number of other means you could have come up with. And that lies at the heart of the central limit theorem, which we'll get to next.